Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 says to draw the Lewis structures of N2H4, N2H2, and just regular diatomic nitrogen. Okay, so let's start off writing the first Lewis structure that contains 2 nitrogens and 4 hydrogens. So before we write Lewis structures, we want to first calculate the total number of valence electrons. In the case of nitrogen, there are 5 valence electrons, and we have 2 nitrogens, so we multiply this by 2. And in the case of hydrogen, hydrogen has 1 valence electron, and we have 4 hydrogen atoms. So if we add these values up, we get a total of 14 valence electrons. So now let's try to write out the Lewis structure over here on the right. We'll have our 2 central atoms be the nitrogen, and then I'll just draw single bonds to each of the hydrogens. Okay, so at this point I like to count out how many electrons I've drawn so far. So each bond contains 2 bonding electrons, and we have a total of 5 bonds, so we have 10 electrons drawn so far, so I just need 4 more. So I'm just going to put a lone pair on each of my nitrogens. Okay, so that's the Lewis structure for part A. Part B is N2H2, so there's 2 less hydrogens this time. And now let's calculate the total valence electrons for this molecule. Nitrogen is 5 electrons times 2, and this time hydrogens is 1 electron times 2. Okay, so then we get a total of 12 electrons for this structure. And again, we're going to start off writing our 2 hydrogens, and then a single bond to each of the hydrogens. So notice that our nitrogens don't have a full octet yet, so I'm just going to draw an extra bond before writing down my lone pairs. Okay, so now let's count out how many I've drawn. So this structure has 12 electrons, everything has a full octet. So this is the correct Lewis structure for our second molecule. And now let's just do it for diatomic nitrogen. The number of valence electrons will just be 5 times 2, which is 10. So let's write our 2 nitrogens single bonded together. And typically with diatomic elements, nitrogen would have this triple bond in between the 2, and then each would carry a lone pair. So let's double check and count out how many electrons are in this structure. We have 2 for each bond, so 6 plus 4. So this is 10 electrons, so this is the correct Lewis structure for diatomic nitrogen. So now let's see what the junior tutor said. For the first structure, step 1 is to list the elements, their valence electrons, and determine the total valence electrons. If a charge is present, add the value of the charge to the total valence electrons when it is a negative charge, and subtract if it's a positive charge. So we didn't need to do that for any of our molecules since they were all neutral. So for the first structure, they got 14. And then they drew it out step by step. So first is the skeletal structure. And then next they added the 2 lone pairs, and that was their final structure. For part B, they did the same thing. They got 12 valence electrons. They made a double bond between the nitrogens. And then lastly, they gave each nitrogen a lone pair. Then for the diatomic nitrogen, they have 10 valence electrons and drew a triple bond. And then finally added the remaining 4 electrons as lone pairs on the nitrogen. Okay, so this solution is correct.